Everybody, welcome to the first lesson of Unit 4. So today we are going to work on graphing rational functions with transformations. So rational functions are a function whose rule is a quotient of two polynomials. So quotient means that it's some sort of division. And so the parent function for this is 1 over x, which we have seen before earlier in the year. We said when we did it that our parent function points were 1, 1 and negative 1, 1, but we're going to add a couple more to that list. So the parent function points for this type of graph are 1/2, comma 2, 1/2, 2, 1, 1, which we already plotted, and then 2, comma 1/2. So 2 and then 1/2 in the y direction. So that creates a leg that looks something like this. And then on the other side, it also has the points of negative 1/2, comma 2. So negative 1/2, negative 2. Negative 1/2, negative 2. Negative 1, negative 1. And negative 2, negative 1/2. So really, those are all kind of the exact same point. So if you can remember the top three, and you can just negate them all, you'll get the other portion of your graph. So those are the parent function points we're going to be working with. And in this scenario, this creates some asymptotes. So we have an asymptote happening here at this x equals 0, and also at this y. So we want to make sure we don't touch that. So we are going to talk about some end behavior here. So this is saying as we're approaching 0, so the x value of 0 from the left side, that's what that little negative means. It means from the left side. So as we get closer to 0 from the left side, our graph is going down. So what that means is because our graph is going down, this is approaching negative infinity. And then as we approach that 0, that x value of 0 from the right side, our graph is going up. It's getting closer and closer and closer to infinity because it's going to keep going up. Okay? Again, this is referring to that left side as we get closer to 0, and this one is referring to that right side as we get closer to 0. And then these ones we have seen before. So as x goes to negative infinity, so as our x values go to negative infinity, as we go this way, we're approaching this asymptote, and this asymptote would be 0. And then as we go to positive infinity, so as our x values go to get really, really, really big, this graph is again approaching that asymptote of 0. So the way we write the domain in interval notation would be negative infinity to that asymptote, union that asymptote to infinity. So basically it's saying everything except for this vertical asymptote of 0. And our range is pretty much the same thing. Negative infinity to 0, 0 to infinity. So this is kind of how we'd write it in interval notation. Another way we could write this is that x does not equal 0 or y does not equal 0. So, and that's because at those values in this situation, we have some vertical and horizontal asymptotes. So that vertical asymptote, this one right here, is represented as x equals 0. We write vertical asymptotes as x equals. So that means we cannot touch that asymptote. That's why the domain is x does not equal 0. And then the horizontal asymptote is going to be y equals 0. So that's because we can't touch this horizontal asymptote, and that's why our range is y cannot equal 0. So onto this function, we can perform some transformations. So this is our parent function. This is where we're starting. But the transformations can kind of change our graph. And those transformations should be nothing new. So the first one is if the a this time is going to be in the numerator rather than necessarily out front. And so if that number is less than 0, meaning that number is negative, then that means we're going to have a reflection over the x-axis. Okay. So if that number is negative, that means we'll have a reflection over the x-axis. Again, that shouldn't be new. If that number is bigger than 1, then that means we're going to have a vertical stretch by A. So by whatever that number is. Now, if that number up top is between 0 and 1, then that would be a vertical shrink also known as a compression. And we do want to specify again that it is by A, by that number. Okay. This time our shift left and right is in that denominator. But that shift is no different than anything we've done before. When we see x minus h, remember we're doing the opposite of what we think, so x minus a number, that means we're actually shifting to the right by h. And when we see x plus a number, x plus h, that actually means we're shifting to the left by h. Okay, and that's in the denominator this time. But our k value, like always, our shift up and down is kind of on the tail end, and it's the same thing as what we think. So if it's a positive k, we're shifting up by k, and if it's a negative k, we're shifting down by k. So when we shift left and right, that vertical asymptote that starts at 0 is going to shift left and right with our graph. So that means that our vertical asymptote is going to be, instead of just like x equals 0, it'll be that left and right shift. So it'll actually be x equals h. And similarly with our horizontal asymptote, it starts at 0, but it will move up and down with our graph. So it's going to be y equals k. So again, our domain is going to be everything except for that vertical asymptote. And that range is going to be everything except for that horizontal asymptote. Again, this could also be written as x does not equal h or y does not equal k. I'm probably going to write it in interval notation today, but these are other acceptable options, as long as you're following the directions, because if it asks you in interval notation, make sure you write it in that interval notation. Okay. So let's graph some. So the first thing we want to do is state the transformations. So here we have 1 over x minus 2 plus 3. So that 1 means that we don't have a vertical stretch or shrink, and it's also not negative, so there's no reflections happening. Again, this is the transformations on the graph of 1 over x. So our transformations here in the bottom, that's going to be the opposite of what we think. So we're actually moving right 2. And then on the outside is the same as what we think, we're moving up 3. So that means that that vertical asymptote that started at 0 is going to also shift to the right 2, meaning that vertical asymptote is going to be 2. And that horizontal asymptote, which started at 0, is going to shift up 3. So it's going to be y equals a positive 3, because it's moving up 3. So then the domain, we can say, okay, that's everything except for that vertical asymptote. So negative infinity to 2, union 2 to infinity. And that range is going to be everything except for that horizontal asymptote. Negative infinity to 3, union 3 to infinity. Okay, I still haven't graphed it yet, and I'll graph it in a minute, because the next thing I want to do is find my y-intercepts. And as always, what we do to find our y-intercept is we're going to plug in 0. So we're going to say 0 minus 2 plus 3. So that's going to give me 0 minus 2 is negative 2, so this will be a negative 1/2 plus 3. And we will have to rewrite that 3 as a fraction. So I can rewrite 3 with a denominator of 2 as 6 over 2. So this is really a positive 5/2. So my y-intercept, we write it as 0 comma some number, 0 comma 5/2. Okay, so now let's go ahead and graph it. So again, that parent function is going to be 1/2 comma 2, 1, 1, 2 comma 1/2, negative 1/2, negative 2, negative 1, negative 1, and negative 2, negative 1/2. That is that parent function. We do need to know that. And so then all I'm doing here is I'm going to take all of those points and I'm going to move them right 2 and up 3. So I'm going to take this, actually I want to do it in a different color. 1/2, comma 2. I'm going to go right 2 and up 3. Right 2, up 3. Right 2 and up 3. And then I'll do the same with these points. Right 2 and up 3. Right 2 and up 3. And right 2 and up 3. And it kind of looks like we got a lot of points going on. So what we can also do to help us out a little bit is we can draw that vertical and that horizontal asymptote. So again, we know that that vertical asymptote is at x equals 2, so that's here. So we want to make sure we're not crossing that. And then we know that that horizontal asymptote is at 3. And so those asymptotes kind of give us restrictions on where we can draw. So what we want to do is get close to them, but we don't want to cross them as we connect those points. So this is what our graph should look like. Okay? And then it does ask us to state the end behavior. And so when I say the end behavior, that's the limit as x approaches negative infinity of f of x. So again, this is the same thing as when we go to the left. We did that in the last unit. So when we go to the left, as we go to negative infinity, we're approaching that asymptote of 3. Okay, we're getting closer and closer to this horizontal asymptote. And as we go to the right, we're also approaching that 3. And the last thing I do want to talk about is zeros. So when we try to find zeros, we find that by setting the equation equal to 0. So this would be like our setup for something like that. But we don't necessarily know how to solve that quite yet. So for right now, because we don't know how to solve that, we're just going to kind of estimate it. We see that we have kind of a point right here where it's crossing that x-axis. So we could say our 0 is approximately, you could say maybe 1.5 or 1.6 repeating, something like that. It's approximately 1.5. We're not really sure. It's actually maybe a little bit more than that because this point is at 1.5. So I'm going to say 1.6. We will learn how to solve that a little bit later, but for right now, we don't really know. So we're just going to estimate it to the best of our abilities. Okay, so that's that first one. So let's move on to the next one. So the next one has some more things going on. So first thing we should hopefully notice is we have a negative. So what that means is we're going to have a reflection over the x-axis. Okay. We also see that that number up top is no longer 1. So that number is bigger than 1. So that's going to be a vertical stretch by 2. And then we're shifting just like we did in the last one. So this time we're shifting to the left 3. Again, it's the opposite of what we think, so left 3. And down 1, because that up and down is the same as what we think. So before I even get to graphing, because that is a lot, my vertical and horizontal asymptotes are not going to be impacted by those reflections or those vertical stretches. Those are only changing because of the left, right, up, and down. So that vertical asymptote, which again starts at 0, is going to move to the left 3. So it's going to be x equals, and to the left 3 would take us to a negative 3. Okay. And my horizontal asymptote, again, is not impacted by the rest of this. It's going to be moving down 1. So it's going to be y equals negative 1. And we do need to make sure we know that vertical asymptotes are x equals and horizontal asymptotes are y equals. And that's because of that left, right, up, down. And then we can say, again, our domain is going to be everything except for that vertical asymptote. And our range is everything except for that horizontal asymptote. Okay. And then we can also find our y-intercept without graphing anything. And again, like always, I get that by plugging in 0 for x. So this one is going to give me negative 2/3 minus 1. So I am going to have to get that with a common denominator. I can rewrite 1 as 3 over 3. So really this is going to be a negative 5/3. And so we'll write this as 0, negative 5/3. Okay, now we'll go ahead and we'll graph it. So again, those parent function points which we need to know are 1/2, 2, 1, 1, 2, 1/2, -1, -1, -1/2, -2, -2, -1/2. Those are not changing between these functions. Okay, so now we need to do our transformations, and this is where it's going to get a little kind of weird. I'm just going to take it one branch at a time. So I'm going to start with this first branch. So I have 1/2, 2. So I'm going to reflect over the x-axis, which is going to take me to 1/2, -2. And then a vertical stretch by 2 is going to multiply the y values. So it's really doubling those y values this time because we're multiplying by 2. So instead of 1/2, -2, it's going to be 1/2, -4, because I took that y value of -2 and multiplied it by 2. And then I'm going to move left 3. So I do need to be careful because I'm still at a 1/2. So 1, 2, 3, and down 1. So that's going to take me here. Okay, we're going to do it a couple more times. So again, I'm just going to work with this first branch first. I have 1, 1. I'm going to reflect it, so it's 1, -1. Vertically stretch it, so doubling those y values, so 1, -2. And then I'm going to go left 3 and down 1. So that's taking me here. And then 2, 1/2, okay, I'm reflecting it, so 2, -1/2. When I double it, what I'm really doing is that -1/2 times 2. And so that's actually going to give me -1. So it actually takes me to kind of a pretty number there, which is nice. Because again, -1/2 times 2 is going to be -1. And then I go left 3 and down 1. Okay, so that gets me my first branch. Now I'm going to move on to the second one. So again, I have -1/2, -2. So I'm going to reflect. That's going to be -1/2, +2. Vertically stretching by 2, so I'm doubling those y values, so -1/2, 4. And then we're going to go left 3, 1, 2, 3, and down 1. So it's going to be right here. Okay, 1, -1 will reflect, so it's -1, 1. Vertically stretch, so it's -1, 2. And then we're going to move left 3, 1, 2, 3, down 1. Last one, -2, -1/2 will reflect to be -2, +1/2. Vertically stretched to be -2, +1, and then it'll go left 3 and down 1. Okay, so again, we do want to plot those asymptotes so we have an idea of where our graph is. So one of them is at -3, that vertical asymptote, and the other one is at -1. So now we can connect our points and make sure we're not crossing those axes, and we're kind of creating somewhat of an L shape, like a curved L, in each of these kind of quadrants. So we'll say our end behavior, the limit as x approaches -infinity of this function. This is again as we're going to the left. It's going to that horizontal asymptote. So we should hopefully start to see a pattern that each time to the left and to the right in this situation, they're going to those asymptotes. So it's going to -1. And as I go to the right, it's still going to -1, right? As I'm going to positive infinity, we're still approaching that asymptote, and we're not crossing it. Again, the zeros, the way we would set that up is by setting this function equal to 0. And if you know how to solve it, that's great. We haven't quite gotten there yet. But we can see here that we actually, when we transformed our points, we got a 0. It's right here at -5. So we can confidently say with no estimation that x equals -5 is going to be one of our zeros. Because we definitely have that point. It's very, very clear. Okay, moving on. Alrighty. So this one we do again have some transformation, so let's start by listing those out. We don't have any reflection because this is positive, but we do have a vertical stretch this time by 3. Because that top number is 3 instead of just 1. Okay, if it's 1, there's no vertical stretch or compression or anything. And then we are shifting left and right. So we're shifting to the right this time, again, opposite of what we think, right 4, and up 2. Okay. So then we're going to do, again, vertical and horizontal asymptotes. So if I'm shifting to the right 4, that means my vertical asymptote is also shifting to the right 4. So that's in the positive direction, so it's going to be x equals 4. And my horizontal asymptote, I'm shifting up 2, so that one's going to be y equals 2. Again, domain is going to be everything except for that vertical asymptote. And the range is going to be everything except for that horizontal asymptote. And the last thing I can find before I graph is that y-intercept. And again, as always, I get that by plugging in 0. So when I do that, this first piece is going to become negative 3/4. And then I'm going to need to get that 2 so that it has a denominator of 4. So I can write that as 8/4. So this is going to be a positive 5/4, which we'll write as 0, 5/4. And that's about all I can get with just this without the graph. So again, parent function points are 1/2, 2, 1, 1, 2, 1/2. And then we have -1/2, -2, -1, -1, and -2, -1/2. Okay, so this is kind of what that parent function looks like. Okay, so now I'm going to perform my transformations. So this one is a little tricky because we do have a vertical stretch by 3. So this time we're tripling those y values. So if I have the point of 1/2, 2, I'm going to triple those y values. I'm going to multiply those y values by 3. So that's going to give me 1/2, 6. And then I still need to move right 4. So 1, 2, 3, 4, and up 2. So that's going to take me all the way over here. And I'll do the same with 1, 1. So 1, 1, we're tripling the y values. We're multiplying by 3. So that'll be 1, 3. And then that's going to move right 1, 2, 3, 4, and up 1, 2. Now this one is a little tricky because we have 2, 1/2. So what we need to be doing is taking that 1/2, that y value, and multiplying it by 3. So that's going to give us 3/2, which you can think of it that way, or you can think of that as, okay, that's like 1.5. So when I do 2, 1/2, and I'm tripling those y values, I'm really going to 1.5. So if you need to go off to the side to multiply things like that out so that you're making sure you're getting the right values, you're more than welcome to do that. So that's 2 and then 1.5, and then we go right 1, 2, 3, 4, and up 1, 2. Here. Okay, so that's our first branch. So let's do our next one. So we have -1/2, -2. Triple the y values, so -1/2, -6. And then we're going right 1, 2, 3, 4, and up 1, 2. We have -1, -1. So we'll multiply the y values by 3. So -1, -3. And then we'll go right 1, 2, 3, 4. And then up 1, 2. And then our last one, again, we're taking -1/2 and we're multiplying it by 3. So that's going to give us -1.5 this time. So -1/2, -1.5. And then we can move right 1, 2, 3, 4, and up 1, 2. So it's actually Funny enough, kind of ending up at a point that we already had. That doesn't always happen. And again, I'm going to draw those asymptotes to kind of make sure when I connect these points that I'm not messing anything up. So we have an asymptote at 4. And then we have another asymptote happening at y equals 2. So these are going to be our asymptotes, the lines we don't want to cross when we connect these points. So we'd connect these points so that they look something like this. Okay. So again, our M behavior, the limit as x goes to negative infinity, as we go to the left, we are approaching that asymptote of 2. And then as we go to the right, our graph is still approaching that asymptote of 2, just from the top or from the bottom. Zeros, as always, we get that by setting this equation equal to 0. And we're just going to kind of estimate it. So we should hopefully see, okay, we're crossing somewhere between 2 and 3. So we're going to estimate that to approximately, and this is a little symbol for approximately, like 2.5. That could be wrong. Again, we don't know how to solve that quite yet. So we're going to approximate it to 2.5. I'd like you to pause the video and try this one on your own. Okay, so let's go through it. So our transformations here, again, that 1, does that mean that we're vertically stretching, yes or no? The correct answer is no. That 1 is just kind of a placeholder there. It doesn't mean a vertical stretch or a vertical compression. So really all we're doing here is shifting to the right 7 and down 5. Okay, so right 7, down 5. So that means that vertical asymptote is going to be x equals 7. Okay, that horizontal asymptote is going to be what? It'll be y equals negative 5. So again, domain is going to be negative infinity to that vertical asymptote to infinity. And the range will be negative infinity to negative 5 to infinity. Everything except for that horizontal asymptote. What'd you get for the y-intercept? We should plug in 0. And then we'd get negative 1/7. And we'd have to rewrite 5 as a as a fraction. So we're going to write that as negative 35/7. So then this would become negative 36/7. And so that's going to be our y-intercept. And we can also kind of check our y-intercepts. Like our last y-intercept was 5/4, which is like 1.25, and that looks roughly correct on our graph. So then we should have graphed it. So again, 1/2, comma 2, 1, 1, 2, 1/2, negative 1/2, negative 2, negative 1, negative 1, negative 2, negative 1/2. And then all we're doing here is taking these points right 7 and down 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 7 and down 5 would take me here. And then 7 and down 5 would take me here. Oh no, I did that too far. Sorry, that's not right. 7 and down 5 would take me here. Okay. And then we do these, so right 7 and then down 5. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay. Right 7, down 5. That one's a little easier. and then right 7 down 5 would be here. And then again, we want to draw those asymptotes. So we have an asymptote at 7 that we don't want to cross, and an asymptote at -5 that we also don't want to cross. So our graphs should look something, and you can extend this if you want, but you don't need to, like this. Okay. And then we should get that our end behavior, again, limit as x approaches -infinity of f of x is going to be that horizontal asymptote, that -5. And as we go to the right as well, we should also get -5. The zeros, again, we set up by setting this equation equal to 0. And it looks like it's going to be 7 point something. I'm going to roughly estimate it to just 7.1 just to be really safe, because it seems like it's getting pretty close there, but I'm not 100% sure. So again, we're just estimating there. Okay, we got one more. I would like you to try this one on your own too. So what are my transformations here? So I have a vertical stretch by 3. And then we're moving right 1 up 2. So vertical asymptote should be x equals 1 because it's moving to the right 1. And horizontal should be y equals 2 because it's moving up 2. So again, domain should be -infinity to 1, union 1 to infinity. We're putting parentheses there because, again, we don't want to include that 1. And range is -infinity to 2, union 2 to infinity. Okay. To find the y-intercept, we're going to plug in 0. This one actually kind of works out nice because we're going to end up getting 3 over -1, which is actually 3 over -1 is -3. So -3 plus 2 is going to give me -1. So my y-intercept is actually 0, -1. Okay. So now we're going to graph it. So 1/2, 2, 1, 1, 2, 1/2, -1/2, -2, -1, -1, -2, -1/2. So those parent function points. Okay. So 1/2, 2, again, is going to be tripled. So it would become 1/2, 6. Okay? And then that's going to go right 1 and up 2. And it's actually going to end up off of our graph. So we don't have to plot it if it ends up off of our graph. You can, but it's not a requirement. So I'm just going to move on to the next point. So 1, 1, we would vertically stretch by 3, so multiply the y value by 3 to get 1, 3. And then I'd take that right 1 and up 2. So that's going to end up here. Again, we have 2 1/2, and so that y value of 1/2 we'd have to multiply by 3, which is going to give me 3/2, or roughly 1.5. So we'd get 2, 1.5, and then I'd move that right 1 and up 2. So that'll take me here. So that's really all I have for that one branch. So now I got to do the other branch. So I'm going to have -1/2, -2. Vertically stretch that by 3 to get me -1/2, -6. And then this one I'd go right 1 and up 2. So this one actually does end up fitting on my graph, so I do want to go ahead and plot it. -1, -1, vertically stretched by 3 would be -1, -3. And then I'm going to go right 1 and up 2. And that is actually the same thing as my y-intercept, so I'm good there. Okay. And I have my last one, -2, -1/2, vertically stretched to give me -2, -1.5. And then I'd go right 1 and up 2. So that's going to take me here. Again, I'm going to plot those vertical and those horizontal asymptotes. So the vertical asymptote is at 1. And the horizontal asymptote is at 2. And then we can connect our points. So this graph should look something like this. And this graph should look something like this. So last thing we'll do is we'll state our end behavior. So as we're going to the left, as we approach negative infinity, what are we approaching? We're approaching 2. And then as we go to the right, as we approach positive infinity, we're also approaching 2. Very, very last thing, we do have a 0. Again, we get that by setting this equation equal to 0. And we're going to approximate that 0 to, like right here where it's crossing the x-axis. So I'm going to approximate it to like negative, you can say 1/2 or 0.5. Anything like that is fine. So please make sure the homework starts right down here, and it is 6 problems. I know that feels like a lot, but we finished this lesson in 36 minutes, so you have the rest of class to really work on this. So please make sure that you do this and you turn it in. Thank you.